Hey guys, let's talk about fluids. We're not going to do all of Chapter 8 from the textbook sitting in front of you. We're going to kind of hit the high points here, so we don't really have time to go into great detail. But what we will do is talk about pressure and velocity of fluids. So when we're talking about pressure of fluids, we're going to let pressure just be capital P for pressure. Da, 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 da. And pressure is simply defined as force over area. Capital A for area. So we got force over area. That's why, if you watch Mythbusters or something, often pressure is measured in PSI. What that means is pounds per square inch. PSI. But we're not going to measure pressure in pounds per square inch. We're going to measure pressure in pascals, which is abbreviated big P little a. The pascal is the standard unit of pressure, and it is equal to 1 Newton per square meter. So we talk about pascals today. So if we just wanted to find the pressure in something, we would want the force, and then we want to divide that by the area. Now, how do you find area? Lots of different ways. Area of a circle is pi r squared. Area of a parallelogram is length times width. Area of a trapezoid is 1/2 b1 plus b2 times h, and so forth. There are lots of different area formulas that you should just know off the top of your head. If you don't know them, conveniently, you're sitting in front of a computer right now, which means you have all of the internet that can tell you these formulas. You won't be able to do that on a test, so you might need to brush up on a little bit of basic geometry. But yeah, know how to find area. Now, just finding pressure in something isn't very interesting. I think we're finally getting to the point where we can solve an equation as simple as this without help. Some of you still try to do it upside down or do it in your head and get confused, but for the most part, like I said, I think we're getting to the point where you don't need that much help doing this. But more interesting is when we use Pascal's principle. And Pascal's principle says this: pressure applied to a fluid in a closed container is transmitted equally to every point of the fluid and to the walls of the container. So this means that if we have, I don't know, just like a can, oops, it's totally filled with fluid. The fluid is pressing in every direction on all the walls with the same amount of force, with the same amount of pressure, that is. Now, how's this idea useful to us? Well, let's think about it. Let's say we have this metal mechanism, like this. So let me explain to you what I've drawn here. This is a giant pink brontosaurus. And what we have here is a casing. This green stuff is a fluid. And these are just metal pylons. And the fluid is totally sealed, but it's under pressure, obviously, because it's got a giant pink brontosaurus on it. But it's at equilibrium right now. It's totally still. All right? So at this point, it's exerting the same amount of pressure in every direction. Now, imagine that I add to this imagine that we stand Andrew Walker on this end. All right? This system was in equilibrium before, but we've just added some amount of weight. We've added a force down. So we've increased the pressure. But even though we've increased the pressure, it's applied equally like at every single point. So yeah, we increase the pressure. Yeah, we do increase the pressure here. Okay, it pushes against him, but we also increase the pressure by the same amount here at every single little point. Notice there's a whole lot more little terribly drawn arrows here than there were here. So this is how hydraulic jacks and things work. That's how we can put something relatively small, like Andrew Walker, on one end of a thing, and have it actually lift a giant pink brontosaurus like this. Now, what's the math look like here? The math is actually quite simple. The pressure increase is equal to force 1 over area 1 is equal to force 2 over area 2. Now what does this mean? What does force 1, force 2, area 1, and area 2 mean? Well, force 1 is this. This is the force down. Area 1 is the area here. Force 2 is going to be the resulting force upward. And area 2 is the area here. So it's just a proportion, and we can all solve proportions. So solving pressure problems about, like, basically hydraulics should be fairly easy for you. So that's all I really have to say about pressure. It's a simple equation we should all be able to solve without very much trouble. So I want to talk about fluid flow now. The flow of fluids. And that means if we have a pipe of a certain width, and then it bottlenecks out to a much wider pipe, what can we say about the flow of the fluid? So if say it's moving at 4 meters per second here, how fast will it be moving when it fills this whole area with the velocity here? So as it turns out, fluid flows much faster, he alliterated, through a smaller cross-sectional area. So it's going to flow much faster here than it is here. So if it's going 4 meters per second there, it might just be going 0.75 meters per second over here. Now, that's easy to compare because we were just looking at cross-sectional area. If we wanted to do a really good problem, we'd have to do some calculus and take some integrals and stuff and consider the shape and the function of the curve of the side and that sort of thing. But we're not going to do anything fancy like that. Really, we're just going to figure out the speed in one area as compared to another. And so we have a very simple equation for this also. This is called the continuity equation. And this equation says the cross-sectional area 1 times the velocity 1 equals the cross-sectional area 2 times velocity 2. So let's say this was 0.5 square meters, half a square meter. And then we said it was going at 4 meters per second. And then we don't know how big that is. And we said it was going in that over there, 0.75 meters per second. Well, when we solve this, we divide both sides by 0.75. So we end up with 2 divided by 0.75, which is 2.6 repeating. So that means the area here would be 2.6 repeating square meters, which is significantly bigger. So that's an easy equation to solve too. Really, it's just a proportion that's already been cross-multiplied for you. So today's problems are pretty easy. Fluid is one of those things that just, I always found it challenging at first, and it's really not that hard. But I think it's just easy to get it backwards or to get confused. So just take your time, work through the problems today. I don't think there are going to be very many. I haven't written them yet as of right this second. So yeah, we'll see. Have fun.